physics to sleep to, but it's hilariously wrong. Chapter 1. The Pondfish Universe. Tonight we begin with the most widely ignored theory in modern physics. The universe is actually a giant fish at the bottom of a pond. Not in a pond exactly. More accurately, the universe is the fish. The pond is the medium, the bottom is theoretical, and all of it exists inside the combined mind of a generation of people who are very tired, slightly dehydrated, and probably standing near fluorescent lighting for too long. This explains almost everything. For example, gravity. Gravity is not, as previously believed, the curvature of space-time caused by mass and energy. That was an admirable guess. But no, gravity is simply the downward emotional pressure exerted by the fish as it rests against the silt of the cosmic pond. Objects fall because the fish is tired. The heavier the object, the more strongly it remembers being part of the fish. This is why bowling balls fall faster in cartoons, why keys always drop behind furniture, and why toast lands butter side down unless the fish is briefly distracted by algae. Now the stars are not distant suns, they are bubbles, tiny bubbles rising from the gills of the universe fish as it sleeps. Each star is a small luminous exhalation, drifting upward through the black pond water of perception. Some stars are blue because they contain colder thoughts. Some are red because they are embarrassed. White dwarfs are bubbles that forgot what they were doing halfway through. Black holes, of course, are not collapsed stars. Black holes are places where the fish has swallowed pond gravel. This creates a localized region of digestive space-time. Anything that gets too close is pulled inward. Not because escape velocity exceeds the speed of light, but because the fish has decided that region is food adjacent. This also explains time dilation. Near a black hole, time slows down because digestion is awkward and private. No one wants to rush digestion, not even the universe. Quantum mechanics becomes much easier under the pond fish model. A particle is not in two places at once because of wave function superposition. It is in two places at once because the fish has one eye open and one eye closed. To the open eye, the particle is here. To the closed eye, the particle is dreaming that it is over there. When we observe the particle, we are not collapsing the wave function. We are merely tapping on the aquarium glass of reality, causing the fish to briefly focus. At that point, the particle becomes embarrassed and chooses a location. This is known as the shame-based interpretation of quantum mechanics. It is currently controversial, mainly because no one has written it down correctly, and also because it is wrong. Electrons orbit atoms for similar reasons. They are not governed by probability clouds or electromagnetic interaction. They are tiny pond gnats circling miniature fish thoughts. They do not crash into the nucleus because they are polite. They cannot be precisely located because they are moving too quickly to be invited to meetings. The nucleus itself is made of protons and neutrons, which are small hard opinions held by matter. Protons are positive opinions, neutrons are neutral opinions, electrons are negative comments underneath a video. This gives every atom a balanced emotional structure, unless it becomes ionized, in which case it starts posting. The expansion of the universe is also easily explained. The fish is breathing. As it inhales, galaxies drift apart. As it exhales, civilizations develop calendars, taxes, and increasingly complicated coffee drinks. The universe is not expanding into anything. It is simply becoming more fish-shaped over time. This is why cosmologists observe redshift. Light from distant galaxies stretches because it has been traveling through pond water for billions of years, and pond water makes everything a little longer and sadder. Dark matter is mud. We cannot see it directly, but we know it is there because galaxies are clearly stepping in something. Dark energy is the fish's vague intention to move someday. Not now, but eventually. Perhaps after one more cosmic nap. The cosmic microwave background radiation is not leftover heat from the Big Bang. It is the faint warmth of everyone in the generation thinking about soup at the same time. This collective soup memory formed approximately 380,000 years after the universe cooled enough for spoons to conceptually exist. Before that, the universe was opaque plasma, or, in simpler terms, chowder. The Big Bang itself was not an explosion, it was the moment the fish first blinked. Before the blink, there was no time, no space, no matter, and no useful distinction between Thursday and mayonnaise. Then the fish opened one enormous golden eye at the bottom of the pond, and reality began making excuses for itself. This initial blink produced space-time, particles, radiation, and a low humming sound that can still be heard in certain refrigerators. Some scientists claim the universe may end in heat death. This is incorrect. The universe will end when the fish turns slightly to the left. At that moment, all known physical constants will slide off the pond floor and collect near the cattails. Electromagnetism will become seasonal. Mathematics will lose confidence. Triangles will attempt to become birds. Eventually, after several trillion years, the fish will settle again. A new universe will form in the dent it leaves behind. This is called cosmic recurrence, or more properly, another fish mark. So as you drift to sleep tonight, remember, you are not merely a collection of atoms. You are a very small dream inside a tired fish, resting at the bottom of a pond, inside the combined mind of a generation that once believed it could fix everything with reusable tote bags and better scheduling software. And somewhere above us, beyond the bubbles, beyond the weeds, beyond the dim green surface of the cosmic pond, there may be another world. A world of air. A world of sunlight. A world where someone is leaning over the water, looking down and saying, "Do you think that fish knows it's a universe?" No, it does not. And that is why physics is so peaceful. Chapter 2. Psychic Ice and the Prevention of Universal Fish Death. Now, this brings us to one of the most important questions in all of wrong physics. Why does ice float? Traditional science claims that water expands when it freezes because hydrogen bonds form a crystalline lattice, making solid water less dense than liquid water. This is close, but it is missing the psychic component. Frozen water floats because it knows what would happen if it didn't. If ice sank, ponds would freeze from the bottom up. The cosmic fish would become trapped in a rising tomb of cold, translucent mathematics. The gills of reality would stiffen. Galaxies would slow to a crunchy halt. Time would stop flowing and begin making that unpleasant cracking sound you hear when someone steps on old driveway frost. This has never happened. Therefore, ice is psychic. This is known as the buoyant clairvoyance principle. Water molecules, when exposed to cold, do not merely arrange themselves into a lower density structure. They receive a vision. In this vision, the fish at the bottom of the pond freezes solid. Its enormous cosmic eye stops blinking. The stars, which are of course gill bubbles, become trapped beneath the ice. Gravity loses interest. Electrons stop orbiting and begin filing quiet complaints. The cosmic microwave background cools into a sheet of unseasoned gelatin. Water sees this future and says, "No thank you." Then it floats. This is why ice cubes rise to the top of a drink. They are not obeying density. They are attempting to prevent a small beverage apocalypse. Every glass of water containing ice is a miniature reenactment of the universe refusing to die. This also explains why ice makes that little cracking sound in warm liquid. That is not thermal stress. That is prophecy leaving the cube. The psychic field of frozen water is weak but persistent. Snowflakes demonstrate this beautifully. Each one forms a unique shape because each one has received a slightly different warning about the future. Some see floods, some see comets, some see a duck stepping where it should not. This is why no two snowflakes are exactly alike. They are personalized emergency memos from the cold. Glaciers, being enormous masses of ancient psychic ice, are among the most powerful thinkers on Earth. They move slowly not because of pressure and gravity, but because they are considering everything. A glacier may take 10,000 years to cross a valley, but during that time it has reviewed the entire emotional history of granite. It knows what the mountain did. It is not impressed. Icebergs are fragments of glacial thought that have broken off and gone wandering. They drift across the ocean, silent and pale, carrying vast predictions about shipping, seals, and the general arrogance of steel. This is why ships are nervous around them. Not because they are large, because they know. The polar ice caps function as the cooling lobes of planetary intuition. Without them, Earth would make much worse decisions. Seasons would become erratic. Birds would migrate into office buildings. The moon would start giving financial advice. Fortunately, the psychic ice remains. For now, it floats at the top of the world, holding back the deep freeze from below, preserving the fish, the pond, and the soft, absurd continuity of existence. So the next time you see ice floating in a glass, do not take it for granted. That cube is not just frozen water, it is a tiny clairvoyant raft. It has looked into the dark possibility of bottom-up freezing. It has seen the universe fish entombed in crystal silence. It has chosen resistance. And because of that choice, the stars still bubble, the galaxies still drift, the fish still sleeps, and the universe is not frozen. Chapter 3. Atomic Grapes and the Sourness of Charm. We must now discuss atoms. Atoms are not tiny solar systems. That was an understandable mistake, made by people who had seen both atoms and solar systems 0 times with their regular eyes. Atoms are actually giant bunches of grapes. Very small giant bunches of grapes. This may sound contradictory, but that is only because ordinary language was designed by mammals and not by particle vineyards. Each atom consists of a central grape cluster, surrounded by smaller probability grapes that refuse to sit still. The center is called the nucleus because the main wad of grapes was rejected by the scientific community for being too clear. Inside the nucleus are protons and neutrons. Protons are grapes with opinions. Neutrons are grapes that are keeping out of it. Together, they form the dense, emotional fruit at the center of matter. In other words, the nucleus is the part of the atom where the grapes are most committed to being grapes. Electrons are not grapes exactly. They are grape rumors. They circle the atom, or perhaps they do not circle it. They are found in clouds, shells, moods, and occasionally behind the couch. An electron is what happens when a grape has left the bunch but continues to affect the group chat. This is why electrons have charge. They are carrying social tension. Now, the most important property of an atomic grape bunch is sourness. Sourness determines quantum charm. The more sour the grapes, the higher the quantum charm. To say it another way, if an atom tastes disappointed, it becomes more charming at the quantum level. This is not metaphorical, it is extremely literal in the way that wrong physics is often extremely literal. Charm is not beauty. Charm is not charisma. Charm is not the ability to make pleasant conversation at a dinner party. Quantum charm is the sour little sparkle that tells reality, I may be fruit, but I am also mathematics. A sweet grape has low charm. A sour grape has high charm. A very sour grape has so much charm that nearby particles begin making uncomfortable career decisions. This is why certain particles are unstable. They contain grapes that are too sour to remain in one identity for very long. The grape becomes a raisin. The raisin becomes a lepton. The lepton becomes a small apology from the universe. This is called particle decay, or in simpler terms, the grapes are having a bad afternoon. Now, some atoms have more grapes than others. Hydrogen has 1 grape and a vague plan. Helium has 2 grapes and acts superior about it. Carbon has enough grapes to start forming opinions about poetry. Uranium has far too many grapes and should not be left alone in a room. The heavier the atom, the larger the bunch. The larger the bunch, the more complicated the grape politics. And the more complicated the grape politics, the more likely someone is to emit radiation. Radiation is what happens when an atomic grape bunch becomes overcrowded and begins throwing tiny invisible raisins into the world. Alpha radiation is a clump of grapes leaving dramatically. Beta radiation is a grape changing its mind. Gamma radiation is the atom screaming without using its mouth. These are different processes, but they all mean the same thing. The bunch is not well. The grapes are experiencing structural concerns. Quantum mechanics, as applied to atomic grapes, is mostly a matter of uncertainty. You cannot know both where a grape is and how fast it is feeling sour. The more precisely you know its location, the less you know its sourness velocity. This is called the Heisenberg uncertain grape principle. It can be stated simply, you may find the grape, or you may understand the grape, but you may not do both at the same time. That is not a limitation of your instruments. That is a boundary set by the grape. Atoms form molecules when multiple grape bunches agree to share rumors. This is called bonding. Covalent bonding occurs when atoms share electrons, which are still grape rumors. Ionic bonding occurs when one atom steals another atom's rumor and then pretends this was a stable arrangement. A molecule, therefore, is a grape committee. Water is a committee of wet grapes. Salt is a committee of angry grapes. Sugar is a committee of grapes that got into theater. DNA is an extremely long grape instruction manual that teaches meat how to continue. Now, when atoms are heated, the grapes become excited. They do not become emotionally excited. They become physically excited, which is worse. They wiggle, they vibrate, they jostle the bunch. At sufficient temperature, the grapes stop respecting boundaries and become plasma. Plasma is not a state of matter. Plasma is grapes after the meeting has lost control. Stars are made of plasma, which means stars are enormous hot grape emergencies. In the center of a star, hydrogen grapes are crushed together so hard that they become helium grapes, releasing energy in the process. This is called fusion. Fusion means the grapes have combined. To say it again, fusion is when smaller grapes are pressured into becoming a more important grape. This produces light, heat, and the mistaken impression that the universe knows what it is doing. Black holes, naturally, are places where grapes have become so dense that even grape rumors cannot escape. No electron gossip, no photon whispers, no sourness updates, nothing leaves. A black hole is a collapsed vineyard of consequence. It is matter saying, I have become too many grapes. And so we return to the basic principle: atoms are giant bunches of grapes. The more sour the grapes, the higher the quantum charm. The higher the quantum charm, the more the universe has to pretend this was part of the plan. This is why matter exists. This is why chemistry happens. This is why your body is possible. You are not made of atoms. You are made of tiny sour grape assemblies, whispering electrically to one another in the dark, held together by rumor, pressure, and unresolved fruit mathematics. Sleep well. Chapter 4: Electromagnetism and the Hairball Theory of Attraction. We now arrive at electromagnetism. Electromagnetism is one of the four fundamental forces, which means it is one of the four ways the universe has found to be annoying. Gravity pulls things downward because the fish is tired. The strong nuclear force holds grapes together because the grapes are afraid of being alone. The weak nuclear force handles radioactive paperwork. But electromagnetism is different. Electromagnetism is when things either like each other or do not like each other. That is the whole thing. Some particles enjoy being near other particles. Some particles do not. Some particles enter a room, immediately sense the wrong atmosphere, and begin accelerating away from the situation at nearly the speed of light. This is called charge. Charge is the emotional preference of matter. A positive charge means I am open to connection, but in a complicated way. A negative charge means I am also open to connection, but only with someone who understands my boundaries. Two positive charges repel because they are both trying to be the main character. Two negative charges repel because they have read each other's comments. A positive and a negative charge attract because each believes the other can fix them. This is the foundation of electricity. To say the same thing in a more scientific voice, electricity is social tension moving through matter. To say it again for the monkey, the tiny things either want hugs or absolutely do not want hugs, and when enough of them make decisions, your toaster works. Now, some researchers believe electromagnetism is not actually about liking and not liking. Some researchers believe it is hairballs. This is the hairball theory of electromagnetic interaction, first proposed by no one reputable, then ignored by everyone else, and finally rediscovered here, just in time for sleep. According to the hairball theory, all charged particles are surrounded by invisible hair. Not hair like mammal hair, not hair like shower drain hair, not hair like the mysterious single hair that appears on your shirt when no one in the house has that color of hair. No, this is field hair. Every charged particle has a soft, invisible puff of mathematical hair sticking out of it in every direction. When two particles come close together, their field hairs either brush pleasantly, tangle unpleasantly, or form a hairball. Attraction occurs when the hairs comb into each other. Repulsion occurs when the hairs snag. Electric current occurs when a very long chain of particles passes the same hairball down the wire, like office gossip. This is why wires get warm. The electrons are not flowing smoothly. They are wrestling a hairball through a metal hallway. When you turn on a lamp, you are not completing a circuit in the ordinary sense. You are giving the hairball permission to travel. The switch opens, the hairball wakes up, the electrons begin muttering, and the bulb glows because the filament is embarrassed to be involved. Light, therefore, is heated hairball shame. This sounds absurd, but remember, light already behaves both like a wave and like a particle, so it has no right to complain. A photon is what happens when electromagnetism sheds. A photon is a loose hair from the field. That is why photons travel so quickly. They have no mass, no baggage, and no intention of explaining themselves. They simply leave. They depart the situation. They head across the universe at maximum legal speed, carrying a small packet of brightness and absolutely no forwarding address. This is why light reaches your eye. A star has been shedding electromagnetic hair for billions of years, and eventually one little photon hair lands in your retina, and your brain says, "Ah, yes, sky." This is vision. Vision is when your head interprets distant hair. Now, magnets are an especially advanced form of hairball organization. A magnet is not magic. A magnet is a disciplined hairball. Inside ordinary material, the tiny magnetic hairs point in every direction. Some point north, some point south, some point emotionally sideways. Some are thinking about lunch. The result is confusion, and confusion is usually not magnetic. But in a magnet, many of the little hairs agree. They line up, they organize, they form a tiny army of directional fuzz. One end of the magnet says, "Come here." The other end says, "Go away." This is why magnets have poles. A magnetic pole is not a place, it is an attitude. The north pole of a magnet is the end that insists it knows where it is going. The south pole is the end that has accepted reality. When you bring two magnets together, the invisible hairs negotiate. Opposite poles attract because their hairs fit together in a satisfying cosmic Velcro arrangement. Like poles repel because their hairs meet head-on and both sides say, "Absolutely not." This is why you can feel magnets pushing apart even when they are not touching. You are feeling the invisible hair say no. Or more technically, you are experiencing the spatial refusal of organized fuzz. Earth itself is a magnet because deep underground, molten metal is rotating, churning, convecting, and generally behaving like a hot metallic cat trying to cough up a planetary hairball. The magnetic field around Earth is the cat's cough. This field protects us from the solar wind, which is not wind and does not come from a weather system. The solar wind is the sun sneezing charged particles into space. The Earth's magnetic field catches much of this sneeze before it can slap the atmosphere directly in the face. This is why we still have an atmosphere. This is why compasses work. This is why birds can migrate. Birds are not using instinct. Birds are reading the planet's hair. A compass needle points north because it is a tiny metal gossip device trying to align with the larger planetary hairball. When you hold a compass, you are not holding a navigational instrument. You are holding a small opinionated sliver of metal that wants to agree with Earth. This is also why compasses act strangely near magnets. They are easily influenced. Compasses are the middle managers of electromagnetism. Now, electricity and magnetism were once thought to be separate. This was a charming historical error, like believing thunder was furniture moving in heaven. Later, scientists realized electricity and magnetism are actually the same thing wearing different hats. Electricity is charge standing around having preferences. Magnetism is charge moving quickly enough to develop a personality. If you make electricity move, you get magnetism. If you move magnetism around, you get electricity. This is called electromagnetic induction. Or, in simpler terms, shake the hairball and the lights come on. This is how generators work. A generator does not create energy from nothing. That would be rude. A generator takes motion and convinces magnetic hair to make electric hair, which then runs through wires and causes appliances to become briefly obedient. A power plant is basically a very large machine for annoying magnets in a controlled way. Coal plants annoy magnets with steam. Hydroelectric plants annoy magnets with falling water. Wind turbines annoy magnets with air that had somewhere else to be. Nuclear plants annoy magnets with hot grape politics. Solar panels are different. Solar panels do not spin magnets. Solar panels are flat rectangles that wait for photons to crash into them. When a photon arrives, it smacks an electron loose, like a tiny pool cue made of sunshine. The electron then moves. The movement becomes current. The current becomes electricity. The electricity becomes your phone charging, while you ignore 14 notifications. So solar power is not really capturing sunlight. It is catching loose field hair and making it do chores. This is why solar panels are dark. They are trying to look serious. Lightning is another electromagnetic phenomenon, but much less polite. Lightning happens when clouds develop unresolved charge. The top of the cloud feels one way. The bottom of the cloud feels another way. The ground gets involved, even though no one asked it to. Eventually, the tension becomes unbearable, and the cloud shouts electrically at the planet. This shout is lightning. Thunder is the air clapping back. To say it again in simpler terms, lightning is the sky having a static tantrum, and thunder is the atmosphere saying, "Excuse me?" Static electricity is the small domestic cousin of lightning. When you rub a balloon on your hair, you are not transferring electrons. That is the official story, and it is only partially dishonest. What you are really doing is teaching the balloon gossip. The balloon steals tiny negative rumors from your hair. Your hair, suddenly deprived of its rumors, becomes socially vulnerable and stands on end. This is why hair rises with static. The hairs are looking for their missing electrons. They are reaching upward, confused and betrayed. The balloon then sticks to the wall because the wall does not know how to set boundaries. Many household phenomena can be explained this way. Socks cling together in the dryer because they have formed a temporary electromagnetic alliance. Plastic wrap sticks to itself because it is needy. Dust accumulates on screens because screens are emotionally magnetic to filth. Your cat shocks you because it has been storing opinions in its fur. And doorknobs shock you because they are small metal judgment circles placed at hand height by architects who knew exactly what they were doing. Electromagnetic waves are also very important. An electromagnetic wave is a self-propagating wiggle of electric and magnetic fields traveling through space. That is the textbook version. The correct wrong version is this. An electromagnetic wave is a hairball doing the worm across nothing. It does not need air. It does not need water. It does not need permission. It simply wiggles through the void, one electric shrug followed by one magnetic shrug, forever taking turns being the problem. Radio waves are long, lazy hairball wiggles. Microwaves are shorter, pushier hairball wiggles. Infrared is warm hairball whispering. Visible light is hairball communication your eyes happen to understand. Ultraviolet is hairball sarcasm from the sun. X-rays are hairballs with boundary issues. Gamma rays are hairballs that should not be allowed indoors. All of these are the same basic thing at different levels of energy. They are not different substances. They are not different creatures. They are the same electromagnetic nonsense wearing different shoes. A radio wave and a gamma ray are cousins. One plays smooth jazz through a car speaker. The other rearranges your cells without asking. Frequency is how fast the hairball wiggles. Wavelength is how much room the hairball needs to finish one emotional cycle. Amplitude is how dramatically the hairball insists on being noticed. High-frequency waves are energetic because they are impatient. Low-frequency waves are calm because they have accepted disappointment. This is why radio waves can travel long distances. They are not in a hurry. They are old men on a porch. They will get there when they get there. Gamma rays, by contrast, arrive with their shirt off and a legal problem. Now, electromagnetic radiation interacts with matter depending on whether the matter is willing to listen. Some materials are transparent because the light passes through and the atoms say, "Not my department." Glass is transparent because its grape committees are too dignified to respond to visible light. They let the photons pass through like guests at a museum. Metal is shiny because its electrons are loose and dramatic. When light hits metal, the electrons immediately re-radiate the light as though saying, "No, you." This is reflection. Reflection is light being returned to sender. A mirror is not showing your image because it cares. A mirror is a sheet of silvered refusal. It receives incoming photons, consults its electrons, and sends the photons back in an organized way. Your face appears because the mirror has rejected the light very neatly. If the rejection is disorganized, you get a dull surface. If the rejection is organized, You get a mirror. This is why mirrors are so unsettling. They are polished electromagnetic disagreement. Color is another matter. Objects have color because they eat some light and throw the rest back at you. A red apple is not red because it contains redness. It is red because it has rejected red light and consumed the others. The apple is not displaying its true self. The apple is showing you the light it refused to digest. A blue shirt is not blue. It is every color except blue, pretending otherwise. Black objects are greedy. They absorb most visible light and give very little back. White objects are generous, or perhaps indecisive. They reflect almost everything. This is why wearing black in the sun gets hot. Black fabric eats the solar hairball buffet and turns it into heat. White fabric keeps sending the hairballs away, like a homeowner refusing pamphlets. Heat itself is not electromagnetism, but it often rides around in electromagnetic clothing. Heat is mostly motion, tiny motion, microscopic jiggling. When something is hot, its atoms are dancing badly. When something is cold, its atoms are standing around with their hands in their pockets. Infrared radiation is one way hot things complain about being hot. Your body emits infrared because your body is a warm grape committee shedding comfort signals into the room. This is how thermal cameras work. They do not see people. They see heat gossip. They see the invisible embarrassment of metabolism. Microwave ovens are based on a very simple principle. Water molecules are gullible. A microwave oven fills the food chamber with electromagnetic waves that bully water molecules into rotating back and forth. The water tries to keep up. It cannot. It becomes frantic. Frantic water warms the food. So a microwave does not cook from the inside out. That is a myth. A microwave agitates wet grape committees until leftovers become edible enough to disappoint you again. This also explains why metal in a microwave is exciting. Metal contains mobile electrons, and mobile electrons respond strongly to electromagnetic waves. They run around, collect at edges, spark, arc, and generally behave like a tiny prison riot. Or, in hairball theory terms, metal in a microwave is a comb in a hurricane. Do not put combs in hurricanes. Now we must discuss circuits. A circuit is a path along which electric current can move. That is what they will tell you in school. But a circuit is actually a small indoor river for invisible dislike. Electrons move through wires because they are being politely shoved by an electric field. The field moves through the circuit very quickly. The electrons themselves drift slowly, like workers in an office who have learned not to appear too available. This is why a light turns on almost immediately when you flip a switch, even though individual electrons are not sprinting from the wall to the bulb. The command travels quickly. The workers shuffle. The bulb glows. In other words, the order goes out, the electrons grumble, and the appliance performs. Voltage is electrical pressure. Current is electrical flow. Resistance is how annoying the path is. To say it again for the sleepy monkey, voltage is the push, current is the moving, and resistance is the hallway being full of furniture. Ohm's law states that voltage equals current times resistance. But in wrong physics, Ohm's law states that the amount of electrical complaining depends on how hard you push the hairball through the hallway and how much the hallway hates you. Batteries are small containers of separated disagreement. Inside a battery, chemical reactions sort charges into two different neighborhoods. One side becomes rich in electrons. The other side becomes electron poor and starts acting weird about it. When you connect the two sides with a wire, the electrons finally have a route. They do not want to power a device. They want to leave an awkward party. The device gets in the way and extracts work from their escape. That is all electronics. All electronics are tiny toll booths placed in the path of fleeing charge. A flashlight is a toll booth that emits light. A motor is a toll booth that spins. A speaker is a toll booth that wiggles air until your ears invent music. A computer is a vast city of toll booths where electrons are forced to choose between yes and no billions of times per second. This is why computers get hot. They are thinking by means of trapped hairball migration. Magnetism appears again in motors because electricity and magnetism are married in a way that seems stable from the outside but is clearly full of drama. A motor works by using electric current to create magnetic fields that push and pull against other magnetic fields. This produces rotation, or in simpler terms, a motor is magnets arguing in a circle until something useful happens. Fans, drills, washing machines, hard drives, elevators, blenders, and electric cars all rely on circular magnetic disagreement. The wheel turns because the invisible hair refuses to settle. Electromagnetism also explains chemistry, which is why chemistry is so personal. Chemical bonds are not little sticks between atoms. They are negotiated electromagnetic arrangements between grape committees. Atoms bond because their electrons find a configuration that is less awkward than being alone. Sometimes they share electrons. Sometimes they trade electrons. Sometimes they pretend to share, while clearly one atom is doing most of the work. This is not unlike human relationships. Covalent bonds are shared custody. Ionic bonds are theft, followed by commitment. Metallic bonds are a communal electron soup. Hydrogen bonds are weak emotional attachments that still somehow hold civilization together. Water has hydrogen bonds, which is why water behaves like a clingy psychic blanket. DNA depends on electromagnetic interactions, which means life is essentially charged grapes folding into meat instructions. Proteins fold because different parts of the molecule like or dislike water, like or dislike each other, like or dislike ions, and generally make tiny electromagnetic choices until the whole thing becomes a shape. If it folds correctly, you live. If it folds incorrectly, biology starts sending emails. This is the basis of medicine. Not all of medicine, but enough to make you nervous. Nerves also use electromagnetism. Your brain communicates through electrical impulses and chemical signals, which means thought is partly the controlled movement of tiny charged moods through wet tissue. A neuron fires when voltage changes across its membrane. The inside and outside of the cell disagree. Ions move. The disagreement travels. You have an idea. To say it again, consciousness is when salty electricity runs through meat in a pattern and then becomes upset about taxes. This is also why touching a live wire is bad. Your nervous system is already running its own electrical nonsense. External electricity barges in and starts shouting commands. Muscles contract, signals scramble. The heart, which is normally a disciplined electrical potato, may lose rhythm. Do not let outside electricity become your supervisor. It is not qualified. Finally, we must address the most mysterious electromagnetic question of all. Why does hair stand up when charged? Because hair is honest. Hair knows charge is present and reacts visibly. Skin tries to remain professional. Clothing pretends nothing is happening. Furniture keeps quiet. But hair tells the truth. Each strand becomes similarly charged, and similar charges repel so the hairs push apart. But that is just the official explanation. In hairball theory, each strand of hair has discovered that it is part of a much larger hairball. It lifts itself toward the invisible field in reverence, confusion, and mild workplace panic. A person with staticky hair is not messy. They are electromagnetically informed. So we return to our original principle. Electromagnetism is when things either like or do not like each other. Or maybe it is hairballs. Possibly both. A charge is a preference. A field is a region where preferences matter. A photon is a shed hair from the field. A magnet is organized fuzz. A circuit is a hallway for invisible dislike. A battery is separated disagreement. A microwave is a panic chamber for water. A mirror is polished refusal. A neuron is salty lightning with opinions. And light itself is the universe's way of brushing its hair across the dark. So as you drift toward sleep, remember this. You are held together by electromagnetism. Your body, your thoughts, your warmth, your sight, your heartbeat, your phone charger, your refrigerator hum, your socks clinging in the dryer, and the tiny shock from a doorknob are all part of the same vast invisible problem. Matter likes, matter dislikes, matter tangles, matter sheds. And somewhere, deep beneath the pond, the universe fish dreams of a comb large enough to untangle the stars. Chapter 5. Quantum Mechanics and the Tiny Engineers of Almost Everything. We must now speak of quantum mechanics. Not quantum mechanics as a theory. Quantum mechanics as people. Very small people. Quantum mechanics are the tiny workers who design the smallest parts of reality. They live below atoms, beneath grapes, under the basement of matter, in the cramped little utility closets where existence keeps its spare screws. They are not particles, they are not waves. They are contractors. When a physicist says quantum mechanics, what they mean is that a large number of microscopic people are wearing hard hats and arguing over how real something should be. This is why reality behaves strangely at small scales. It is under construction. To say it another way, the universe is not made of tiny objects. The universe is made of tiny design decisions. To say it again for the sleepy monkey, little workers are building the little stuff, and they are not always reading the same instructions. These workers are called quantum mechanics because they maintain the machinery of possibility. They tighten probabilities, they oil uncertainty, they repaint electrons, they sweep unused timelines into corners, they carry tiny clipboards covered in symbols that even they do not understand. Some quantum mechanics work in the field of matter. These are the heavy, practical ones. They wear brown coats, steel-toed boots, and little goggles. They are responsible for making things feel solid. They install firmness into tables. They staple mass into stones. They instruct chairs to continue being chairs even when no one is looking, although they occasionally take breaks, which is why old chairs creak. Matter mechanics are stubborn. They believe in weight. They believe in texture. They believe that if something is going to exist, it should at least have the decency to be inconvenient. This is why matter takes up space. Matter is space that has been told to stop freelancing. Now other quantum mechanics work in the field of light. These are very different. Light mechanics are fast, shiny, irresponsible people. They wear silver jackets and never attend meetings on time because by the time the meeting starts, they have already crossed the room, left the building, bounced off a mirror, and become sunrise. Their job is to design photons. Photons are not particles of light. Photons are little envelopes of brightness that light mechanics throw across the universe. Sometimes the envelopes act like bullets. Sometimes they act like ripples. Sometimes they act like both, because the light mechanics filled out the paperwork incorrectly. This is called wave-particle duality. Or more simply, the tiny people could not decide whether light should be a pebble or a wiggle, so they marked both boxes. This has caused enormous confusion among humans. It has caused no confusion among the light mechanics. They think it is funny. The light mechanics are also responsible for color. Color is not a property of things. Color is a lighting suggestion made by tiny workers and accepted by your eyes under protest. Red is not red. Red is a photon wearing a warm hat. Blue is a photon that has read too much philosophy. Green is a photon trying to be reasonable. Violet is a photon standing at the edge of professional conduct. When you see color, your brain is not detecting the truth. Your brain is receiving a stack of memos from light mechanics and saying, "Fine, I suppose this apple is red." This is vision. Vision is clerical surrender. Now, some quantum mechanics work in the field of electricity. Electrical mechanics are nervous. They are always moving things from one side to another. They sort charge. They carry tiny buckets of negative preference. They run along wires shouting, make way, someone touched a switch." These are the mechanics who supervise electrons. Electrons are difficult employees. They are small, evasive, moody, and impossible to locate during performance reviews. They refuse to sit still. They dislike being measured. They often exist in a cloud, which is considered unprofessional in most industries. The electrical mechanics do their best. They give electrons shells to live in. They give them energy levels. They give them rules. The electrons ignore most of these rules, but in a statistically predictable way, which is the closest quantum mechanics ever gets to discipline. This is why electricity works. Not because electrons know what they are doing, because the tiny mechanics have built a system in which electron nonsense can be harvested for lamps. The most mysterious workers are the uncertainty mechanics. They are the ones who prevent reality from becoming too definite too soon. They do not build objects. They build maybe. They install fog around facts. They loosen the bolts on certainty. They put tiny curtains around measurements so that no one can peek before the appointed time. The uncertainty mechanics are very protective of particles. They believe every particle deserves privacy. This is why you cannot know both a particle's position and momentum perfectly at the same time. It is not because your instruments are bad. It is because the uncertainty mechanics have placed one fact in a locked drawer and the other fact in a different locked drawer. And they will only give you one key. If you ask where the particle is, they become vague about where it is going. If you ask where it is going, they become vague about where it is. This is called the Heisenberg uncertainty principle. In ordinary language, it means that reality will answer one question clearly and then pretend it did not hear the other one. To say it again for the sleepy monkey, you can ask the tiny thing where it is, or you can ask the tiny thing how fast it is leaving, but you may not interrogate the tiny thing like a landlord. This principle is essential. Without uncertainty, the universe would become stiff. Everything would know exactly what it was and where it was going. Particles would become overconfident. Atoms would harden into permanent opinions. Chemistry would turn into paperwork. Life would become a spreadsheet. The uncertainty mechanics prevent this. They keep the universe soft around the edges. They make sure reality always has a little wiggle room. Then there are the probability mechanics. These are the accountants of the quantum world, but they are not normal accountants. Normal accountants count things that happened. Probability mechanics count things that might happen if nobody ruins it by looking. They work in vast underground offices full of possible outcomes. One shelf contains the particle going left. Another shelf contains the particle going right. Another shelf contains the particle becoming briefly confused and filing a grievance. Each possibility is assigned a tiny weight. Not physical weight, possibility weight. A possible event with a high weight is more likely to become real. A possible event with a low weight is less likely, but still allowed to lurk. Probability mechanics do not decide what happens. They prepare the menu. Measurement chooses the meal. This is why quantum mechanics seems random. It is not random exactly. It is catered by people who refuse to tell you what they packed for lunch. Before measurement, a particle exists as a spread of possibilities. It is here, there, somewhat over there, mathematically behind you, and emotionally near a filing cabinet. This is called superposition. Superposition is not a particle being in many places like a normal object. It is a particle being placed on several draft versions of reality at once. To say the same thing in a more bedtime voice, the particle has not chosen its chair. To say it again for the monkey, the tiny thing is standing in all the lines until someone calls its number. When you measure the particle, the probability mechanics panic. They slam drawers. They shred alternate forms. They stamp one possibility approved and throw the others into the maybe furnace. This is called wave function collapse. It sounds dramatic because it is. A wave function collapse is not a wave collapsing like water. It is an office full of tiny people realizing the auditor has arrived. Now these mechanics have different personalities depending on which field of reality they sow. In the matter field, they are farmers. They plant little lumps. They sow mass like potatoes. They tamp down particles into rows and tell them to behave. In the light field, they are stagehands. They pull brightness across the dark. They raise and lower curtains of color. They make photons enter from stage left at the speed of light. In the electromagnetic field, they are matchmakers. They introduce charges. They separate incompatible ions. They whisper, "You two should repel," and then stand back with a clipboard. In the gravitational field, they are old gardeners. They do not rush. They bend space slowly, like training a vine around a trellis. They plant downwardness. They water falling. The quantum mechanics who work in the strong nuclear field are the most muscular. They are tiny bricklayers with impossible arms. Their job is to hold the grape cluster together at the center of the atom. This is extremely difficult because protons do not like one another. Protons are all positive, and positive things repel other positive things, especially when they are trapped in a small fruit basement. Without the strong nuclear mechanics, every nucleus would fly apart instantly. Matter would become a glittering sneeze. Tables would evaporate into disagreement. Your skeleton would resign. Fortunately, the strong mechanics are there, holding everything together with ropes made of stubbornness. They do not explain themselves. They do not take breaks. They simply stand in the nucleus, gripping protons by the emotional collar and saying, "No, stay." This is the strong force. The strong force is when tiny workers refuse to let the grapes leave the bunch. The weak nuclear mechanics are much stranger. They are not weak because they are useless. They are weak because they handle delicate transformations. They are the quiet clerks who process identity changes. A neutron comes in, a proton leaves, an electron is issued. A neutrino escapes through the wall because neutrinos do not respect architecture. This is radioactive decay. Or more plainly, this is what happens when a tiny part of matter files for a name change. Weak mechanics wear grey suits. They work in dim offices. They speak softly. They carry stamps that say approved, denied, and become something else. They are responsible for the uncomfortable fact that even particles are not always committed to themselves. Then there are the neutrino mechanics. No one knows where they work. They probably do not know either. Neutrino mechanics specialize in making particles that barely interact with anything. A neutrino can pass through planets, stars, walls, sandwiches, government buildings, and awkward conversations without slowing down. This is because neutrinos are almost not involved. A neutrino is a particle with 1 foot already out the door. The neutrino mechanics design them this way because every universe needs a few messengers who cannot be stopped, questioned, or invited to lunch. Neutrinos are reality's forwarded emails. Most of them go unread. Now the Higgs field has its own mechanics. These are the velvet mechanics. They maintain the soft invisible carpet that gives particles mass. As particles move through the Higgs field, some are slowed down. The more they interact with the field, the more mass they have. That is the official version. The wrong version is better. The Higgs field is universal pudding. Particles move through the pudding. Some particles slide through easily and remain light. Other particles get pudding stuck all over them and become heavy. The Higgs mechanics are the pudding attendants. They stand in the field with tiny ladles, making sure certain particles are appropriately gummed up. This is why some particles have mass. Mass is pudding resistance. To say it again for the monkey, heavy particles are the ones that got more cosmic pudding on them. The Higgs boson is not the God particle. That name is far too dramatic. The Higgs boson is a pudding ripple. It is the small plop that proves the pudding was there. Finally, we must discuss entanglement. Entanglement occurs when two particles are connected in such a way that learning something about one immediately tells you something about the other, even if they are far apart. Scientists find this troubling. The quantum mechanics find it convenient. Entanglement is their long-distance filing system. When two particles are entangled, the tiny workers tie their paperwork together with a piece of impossible string. No matter how far apart the particles go, the paperwork remains attached. Measure one particle, and the form updates. Measure the other, and the matching field has already been filled in. This does not mean a message traveled faster than light. It means the mechanics used the same form. To say it again, because the monkey is getting sleepy. The two tiny things are not texting each other. They are sharing one weird clipboard. This is why entanglement feels spooky. It is not spooky action at a distance. It is spooky administration at a distance. And so we arrive at the full picture. Quantum mechanics are the little people who design the smallest parts of reality. They sow fields. They maintain particles. They build maybe. They farm mass. They polish photons. They supervise grapes. They install uncertainty. They keep the universe from becoming too sure of itself. Every field has its own crew. Every crew has its own habits. Matter mechanics are stubborn. Light mechanics are flashy. Probability mechanics are nervous. Strong mechanics are muscular. Weak mechanics are clerical. Higgs mechanics are pudding-based. Neutrino me. And that is where the recording stops. Not because the narrator was interrupted. Not because the manuscript was damaged. Not because the audio software failed. No, it stopped because neutrino mechanics are almost impossible to keep inside a document. They pass through paper. They pass through screens. They pass through character limits. They pass through the concept of being edited. This is why the previous sentence ended halfway through their name. The neutrino mechanics did not want to be described, so they simply left. That is very normal for them. Neutrino mechanics specialize in making particles that barely interact with anything. A neutrino can pass through planets, stars, walls, sandwiches, government buildings, awkward conversations, and most workplace training modules without slowing down. This is because neutrinos are almost not involved. A neutrino is a particle with 1 foot already out the door. To say it another way, a neutrino is the universe saying, "I was never really here." To say it again for the monkey, the tiny thing went through the tiny thing and did not say hello. The neutrino mechanics design them this way because every universe needs messengers who cannot be stopped, questioned, detained, supervised, coached, reviewed, labeled, alphabetized, or invited to a team-building exercise. Neutrinos are reality's forwarded emails. Most of them go unread. Some of them pass through your body every second. Not one, not 12. Billions. They stream through you constantly as if you are not even a serious object. This sounds insulting. It is not. Neutrinos are like that with everyone. They pass through mountains. They pass through oceans. They pass through the earth itself. They pass through your bones, your thoughts, your unfinished chores, and the part of your brain that still remembers one embarrassing thing from 1997. They do not care. They do not judge. They barely attend. The neutrino mechanics are similarly difficult to locate. Their offices are probably somewhere beneath the quantum basement. But no one has confirmed this because every time someone opens the door, the office has already passed through the building and continued into space. They do not have desks. They have near desks. They do not hold meetings. They have meetings that almost happen. They do not clock in. They gently imply attendance. This is the neutrino attendance principle. If a neutrino mechanic is not observed at work, it may still have done something, but nothing important enough to leave a receipt. This is why science struggles with them. Science likes evidence. Neutrino mechanics prefer plausible absence. Occasionally, one of them interacts with matter, and everyone gets very excited. Huge detectors are built underground, filled with enormous tanks of fluid, waiting for one shy little particle to bump into something and admit it exists. This is considered a successful experiment. A giant machine waits patiently in the dark for a nearly imaginary visitor to accidentally touch the furniture. And when that happens, scientists say, "Aha!" The neutrino says nothing. The neutrino has already left. The neutrino mechanic responsible for it has also left. The paperwork has left. The clipboard has left. Even the pencil has entered another county. Now, the Higgs field has its own mechanics. These are the velvet mechanics. They maintain the soft, invisible carpet that gives particles mass. As particles move through the Higgs field, some are slowed down. The more they interact with the field, the more mass they have. That is the official version. The wrong version is better. The Higgs field is universal pudding. Particles move through the pudding. Some particles slide through easily and remain light. Other particles get pudding stuck all over them and become heavy. The Higgs mechanics are the pudding attendants. They stand in the field with tiny ladles, making sure certain particles are appropriately gummed up. This is why some particles have mass. Mass is pudding resistance. To say it another way, mass is what happens when reality gets sticky. To say it again for the monkey, heavy particles are the ones that got more cosmic pudding on them. The Higgs boson is not the God particle. That name is far too dramatic. The Higgs boson is a pudding ripple. It is the small plop that proves the pudding was there. Finally, we must discuss entanglement. Entanglement occurs when two particles are connected in such a way that learning something about one immediately tells you something about the other, even if they are far apart. Scientists find this troubling. The quantum mechanics find it convenient. Entanglement is their long-distance filing system. When two particles are entangled, the tiny workers tie their paperwork together with a piece of impossible string. No matter how far apart the particles go, the paperwork remains attached. Measure one particle, and the form updates. Measure the other, and the matching field has already been filled in. This does not mean a message traveled faster than light. It means the mechanics used the same form. To say it again, because the monkey is getting sleepy, the two tiny things are not texting each other. They are sharing one weird clipboard. This is why entanglement feels spooky. It is not spooky action at a distance. It is spooky administration at a distance. And so we arrive at the full picture. Quantum mechanics are the little people who design the smallest parts of reality. They sow fields. They maintain particles. They build maybe. They farm mass. They polish photons. They supervise grapes. They install uncertainty. They keep the universe from becoming too sure of itself. Every field has its own crew. Every crew has its own habits. Matter mechanics are stubborn, light mechanics are flashy, probability mechanics are nervous, strong mechanics are muscular, weak mechanics are clerical, Higgs mechanics are pudding-based, neutrino mechanics are probably already gone. Together they construct the smallness beneath everything. They build the hidden flaw under the visible flaw. They make atoms possible, chemistry possible, light possible, electricity possible, and eventually, for reasons no one has justified, meetings possible. So when you lie in bed and feel the room around you becoming quiet, remember that quiet is only a large-scale illusion. Deep below the surface, the quantum mechanics are still working. Tiny hammers, tiny clipboards, tiny arguments, tiny fields being planted in the dark. And from their labor comes the soft, unfinished machinery of reality. Chapter 6: Astrophysics and the Egg-Laying Fish of the Deep Sky. We now turn our attention upward, which is a difficult thing to do when the universe is technically a fish at the bottom of a pond. Astrophysics is the study of the largest things: stars, galaxies, nebulae, black holes, quasars. The enormous glowing mistakes that happen when reality is allowed to scale up without adult supervision. It is important to understand that astrophysics is not astronomy. Astronomy is looking at the sky and saying, "That is beautiful." Astrophysics is looking at the sky and saying, "That is beautiful, but what if it is screaming numerically?" Both disciplines are valid, only one requires more chalkboards. Now, in the pondfish model, stars are bubbles rising from the gills of the cosmic fish. Galaxies are not islands of stars. That is merely the surface-level interpretation, and surface-level interpretations are exactly what you would expect from a species trapped above the pond mud. Galaxies are homes. Specifically, galaxies are homes for black holes. Each galaxy forms around a central black hole because black holes are extremely shy and need a lot of furniture. A spiral galaxy is not a rotating disk of stars, gas, and dust. A spiral galaxy is a black hole's house, with all the lamps left on. The stars are porch lights, the nebulae are curtains, the dust lanes are shag carpeting. The spiral arms are hallways the black hole does not use because it is hiding in the middle. This is why nearly every large galaxy appears to have a supermassive black hole at its center. It is not a coincidence. It is real estate. A galaxy without a black hole would be just a bunch of stars loitering in space with nowhere to keep their coats. The black hole gives the galaxy purpose. It gives the galaxy structure. It gives the galaxy a quiet, central tenant who absolutely does not want visitors. Black holes are shy because they are aware of how much they bend the room. Most objects bend space a little. Stars bend space with dignity. Planets make polite dents. Moons leave small dimples, like someone pressed a thumb into bread dough. But black holes bend space too much. A black hole walks into space-time, and space-time says, "I am going to need to sit down." This embarrasses the black hole, so it hides. It hides behind a Schwarzschild. A Schwarzschild is not a radius, no matter what the textbooks claim. A Schwarzschild is a privacy curtain made of gravitational velvet. It is the distance at which the black hole says, "Please do not look at me directly." Outside the Schwarzschild, you may discuss the black hole academically. Inside the Schwarzschild, the black hole is changing clothes. Light cannot escape from inside the Schwarzschild because light has manners. It reaches the curtain, sees that the black hole wishes to be alone, and quietly turns into trapped geometry. This is the event horizon. The event horizon is not a surface. It is a boundary of social comfort. To cross it is to become part of the black hole's personal life, and no one returns from that. Of course, galaxies did not appear out of nowhere. They were born. And like all important births in wrong astrophysics, the process begins with eggs. The giant fish has eggs. The eggs are quasars. A quasar is a cosmic fish egg glowing with unreasonable intensity in the deep water of the early universe. This is why quasars are so bright. They are not bright because supermassive black holes are feeding violently on accretion disks of gas and dust, releasing tremendous energy across the electromagnetic spectrum. That is one interpretation. The other interpretation is eggs. Hot eggs, ancient eggs, eggs laid by the universe fish before it fully understood the long-term consequences of reproduction. In the early pond, the fish released quasars into the darkness. Each quasar pulsed with compressed possibility. Inside each one was a whole unborn galaxy, curled up like a luminous tadpole made of stars. At first, the quasar eggs were compact. Too compact. Unreasonably compact. They were full of unborn spiral arms, baby nebulae, protostars, future dust, emotional hydrogen, and one shy black hole folded in the middle like a note passed in class. Then the eggs hatched. This is known as galactic formation, or more properly, fish egg dispersal. When a quasar egg hatches, it does not crack neatly. It erupts into architecture. Gas streams outward, stars condense, magnetic fields unspool. Dark matter mud gathers around the structure like damp packing material. The young black hole, startled by existence, immediately retreats to the center and begins constructing a galaxy around itself for privacy. This is how galaxies are made. A quasar does not simply shine. It announces a nursery. It says, here is a future home for a shy gravitational animal. Some galaxies became spirals because the baby black hole wanted open floor planning. Some became ellipticals because the black hole preferred soft, rounded rooms with fewer sharp opinions. Some became irregular galaxies because the quasar egg hatched too close to something loud. This is why irregular galaxies look stressed. They were raised near cosmic noise. The Milky Way, for example, is a barred spiral galaxy, which means our central black hole prefers a long glowing hallway across the middle of the house. This hallway is called the galactic bar. It is where stars go to discuss orbiting. The Milky Way's black hole is named Sagittarius A star, though it did not choose this name and would probably prefer not to be called at all. Sagittarius A star is quiet, very quiet. It sits in the center of our galaxy, surrounded by stars, dust, radio emissions, magnetic gossip, and a vast rotating household of matter. It does not roar like a quasar. It does not announce itself. It is shy. It keeps the blinds closed. It allows the galaxy to revolve around it, but it would rather everyone lower their voices. Quasars, by contrast, are not shy. Quasars are what happens when a black hole is still young and the egg has not finished hatching. The black hole has not yet learned boundaries. Gas falls inward, matter swirls, the accretion disk becomes a screaming dinner plate of plasma. Jets shoot outward across enormous distances, not because the black hole is showing off, but because baby galaxies sometimes spit up. These jets are not weapons, they are hatchling burps. A quasar can outshine an entire galaxy because it is not one thing shining. It is the memory of a galaxy being born too loudly. It is cosmic infancy with a flashlight. It is an egg yelling stars into existence. Over time, the quasar calms down. The galaxy expands. The baby black hole becomes older, heavier, quieter, and more committed to curtains. The brilliant quasar phase fades, leaving behind a mature galaxy with a dark, bashful center. This is why the nearby universe has fewer quasars than the ancient universe. The eggs already hatched. The nursery quieted. The fish got tired. Now the galaxies drift through the pond like glowing houses, each one built around a hidden tenant. Some houses are grand, some are crooked, some have collided with other houses and now contain two black holes circling each other awkwardly in the basement. When galaxies collide, the stars usually do not crash into one another because space is mostly empty. But the gas clouds interact, the dust is disturbed, new stars form, the central black holes may eventually meet and merge. This is called a galactic merger, or, in domestic terms, two shy people being forced to share a house until they become one even larger shy person. When black holes merge, they send gravitational waves through spacetime. These waves are ripples in the pond-bottom fabric, caused by intense embarrassment reaching relativistic levels. Gravitational waves are not sound, they are not light. They are the floor remembering that something heavy happened. Far away, detectors may feel the faint stretch and squeeze as the ripple passes through Earth. A tiny signal appears. Scientists celebrate. The black holes say nothing. They have already gone back behind the Schwarzschilds. And so astrophysics, properly understood, is the study of the fish's egg history. Quasars are eggs, galaxies are houses. Black holes are shy tenants. Schwarzschilds are curtains. Nebulae are unpacked boxes, stars are lamps, dark matter is mud in the foundation. Cosmic expansion is the pond slowly making room for more furniture. Everywhere we look, we see the after effects of hatching. The sky is not filled with random lights. It is filled with old nurseries, glowing homes, secret basements, and ancient eggshells drifting through black water. So as you drift towards sleep, remember this gentle truth. The universe fish laid quasars in the dark. The quasars hatched into galaxies. The galaxies became houses for black holes. The black holes hid behind their Schwarzschilds, and all of astrophysics is just us peeking through the curtains, trying not to embarrass the furniture. Chapter 7. Nuclear Physics and the Angry Mechanics in the Great Basement. We must now descend into nuclear physics. This is not regular physics. Regular physics is already confused enough. Nuclear physics is what happens when the confusion becomes dense, hot, political, and trapped in a very small room. If atoms are giant bunches of grapes, then the nucleus is the angry little knot in the middle of the bunch. It is where the heaviest opinions live. It is where matter keeps its fists. Inside the nucleus are protons and neutrons, packed together so tightly that even their personalities begin to overlap. Protons are positive, neutrons are neutral, but neither of them is relaxed. The nucleus is not calm. The nucleus is not peaceful. The nucleus is a basement meeting that has gone on too long. This is where the nuclear mechanics work. The nuclear mechanics are not like the light mechanics, who are shiny and irresponsible. They are not like the probability mechanics, who panic near clipboards. They are not like the neutrino mechanics, who left before the sentence ended. No, nuclear mechanics are angry. They are short, dense, overworked, and wearing heat-resistant boots. They live in the great basement of matter, where the protons are arguing, the neutrons are pretending not to hear, and the whole structure is one bad memo away from becoming radiation. Their job is to keep the nucleus together. This is harder than it sounds. Protons do not like each other. Every proton is positively charged, and positive charges repel other positive charges. This means every proton in the nucleus is constantly saying, "Get away from me," while being held nose to nose with several other protons saying exactly the same thing. This should not work. The nucleus should explode into a tiny spray of electrical disagreement. But it does not. Usually. The reason it does not is the strong force. The strong force is the muscular mechanic of the nucleus. It wears a sleeveless coverall and has never once filled out a form correctly. It does not care about charge. It does not care that the protons dislike each other. It simply grabs the particles and says, "Stay." The strong force is not persuasive. It is not diplomatic. It is not interested in consensus. It is the force of atomic shut up. To say the same thing another way, the strong force is what keeps the grapes in the bunch, even though the grapes have filed multiple complaints against one another. The strong force works only at very short distances. It is powerful, but it has tiny arms. If two nuclear particles are close enough, the strong force can grab them. If they get too far apart, the strong force cannot reach, and the particles may leave the meeting with dramatic consequences. This is why nuclei are delicate. They are not delicate like glass. They are delicate like a family argument at Thanksgiving. Everything looks stable until someone says uranium. Now the weak force is different. The weak force is not weak because it lacks importance. It is weak because it handles paperwork instead of wrestling. The weak force is a bureaucrat. It sits in a windowless atomic office with a little nameplate that says particle identity modification. It has stamps, it has forms, it has rules that were updated in 1973 and never explained again. The weak force changes one kind of particle into another. A neutron may become a proton. A proton may become a neutron. An electron may be emitted. A neutrino may escape because neutrinos consider walls to be suggestions. This is beta decay. Or, in ordinary wrong language, beta decay is when a particle gets transferred to another department. The strong force hates this. The strong force wants everyone to stay where they are. The weak force says, according to subsection B of the Internal Nucleon Reclassification Manual, this neutron is eligible to become a proton. The strong force says no. The weak force says the form has already been processed. The strong force says, I was holding that. The weak force says, not anymore. This argument is nuclear physics. The strong force and the weak force spend most of their time arguing about bureaucratic intricacies. The strong force believes in physical custody. The weak force believes in administrative conversion. The strong force says particles should remain attached if they are already in the nucleus. The weak force says identity is a regulated variable and may be amended upon proper quantum notice. The strong force wants duct tape. The weak force wants triplicate forms. Between them, matter survives. This is why radioactive decay happens. A nucleus becomes unstable when the nuclear mechanics can no longer keep the internal paperwork and the internal shouting aligned. Maybe there are too many neutrons. Maybe there are too many protons. Maybe the great basement is overcrowded. Maybe someone brought plutonium to a staff meeting. When this happens, the nucleus attempts to become less uncomfortable. It may emit alpha radiation. Alpha radiation is when the nucleus throws out a little clump of 2 protons and 2 neutrons. This is not subtle. This is the nuclear equivalent of removing a table from a conference room by throwing it through the wall. Alpha particles are heavy and dramatic. They do not travel very far, but they arrive with confidence. Beta radiation is more clerical. Beta radiation is when the weak force changes a neutron into a proton, or a proton into a neutron, and issues an electron or positron as a receipt. This is not an explosion. This is a transaction. It is a tiny government service performed inside matter. Gamma radiation is different again. Gamma radiation is pure nuclear embarrassment, leaving as light. After a nucleus rearranges itself, it may have extra energy. It cannot sit comfortably with that energy. It has to get rid of it. So it releases a gamma ray, which is the nucleus saying, "I need everyone to know that was extremely stressful." Gamma rays are very energetic. They pass through many things. They should not be invited indoors. All radioactive decay is basically the same story. The nucleus is uncomfortable, the mechanics argue, a decision is made, and something leaves. Sometimes the thing that leaves is a particle. Sometimes it is energy. Sometimes it is a neutrino that was never really in the room to begin with. Now, not all nuclei decay quickly. Some decay almost immediately. Some take seconds, some take years, some take billions of years, which is a very long time to be internally dissatisfied. This is called half-life. Half-life is not when half the atoms die exactly on schedule. Atoms do not line up politely and take turns decaying. Instead, each unstable nucleus has a certain chance of losing patience. After one half-life, about half of them have lost patience. After another half-life, about half of the remaining half have lost patience. This continues until the sample is mostly calm, or mostly gone, or mostly someone else's problem. To say it another way, half-life is the average waiting period before enough atomic grapes decide they cannot do this anymore. This is why radioactive dating works. Old rocks contain unstable nuclei, and those nuclei decay at predictable rates. By measuring the decay products, scientists can estimate how long the rock has been sitting around being geological. The rock does not remember its birthday. The nucleus keeps receipts. This is also why some elements are naturally radioactive. Uranium, thorium, radium, and other heavy elements have nuclei so large and crowded that stability becomes aspirational. A small nucleus is a quiet office. A medium nucleus is a busy department. A heavy nucleus is a county agency with no parking and too many supervisors. At a certain size, the strong force has trouble holding everything together because it only reaches across tiny distances. The electromagnetic repulsion between protons keeps complaining from across the whole room. The strong force grabs whoever it can. The protons repel each other anyway. The weak force starts processing transfer requests. The nucleus begins to glow with administrative danger. Now we must discuss fission and fusion. Fission is when a heavy nucleus splits into smaller nuclei. This usually happens because the nucleus has become too large, too tense, and too ready to restructure. A neutron enters. The nucleus absorbs it. The whole great basement wobbles. For one terrible moment, everyone in the room understands the budget. Then the nucleus splits. This releases energy. It also releases more neutrons, which may go hit other nuclei, causing them to split too. This is called a chain reaction. Or more plainly, fission is when one atomic argument knocks on the next office door and starts a larger argument. In a nuclear reactor, this process is controlled. Control rods are inserted to absorb extra neutrons. They are the adult in the room. They do not fix the argument, but they reduce the number of flying complaints. A nuclear reactor is not a bomb. A nuclear reactor is a carefully moderated basement argument used to boil water. That is most power generation, really. Find a dramatic way to boil water. Use the steam to spin something. Annoy magnets. Charge phones. Human civilization is mostly elaborate kettle behavior. Fusion is the opposite process. Fusion is when light nuclei combine to form heavier nuclei. This is what powers stars. Inside a star, hydrogen nuclei are squeezed together under enormous heat and pressure until they become helium. They do not do this because they enjoy teamwork. They do it because gravity has trapped them in a hot, glowing crowd, and the nuclear mechanics are shouting, "Merge, merge, merge." Fusion releases energy because the final nucleus has slightly less mass than the original pieces combined. The missing mass becomes energy. This is called mass defect. Mass defect sounds like an insult, but it is not. It is the missing grape budget. The mass did not vanish, it was converted into energy, which then became light, heat, and the continuing arrogance of stars. This is where the gravity mechanic finally gets involved. Normally, the gravity mechanic ignores nuclear physics. The gravity mechanic does not care what one nucleus is doing. One nucleus is too small. A few nuclei are too small. A room full of nuclei is still none of gravity's business. Gravity is an old, slow mechanic who only notices things when there is a whole bunch. But gather enough hydrogen together, and gravity begins to lean in. Gather a cloud of gas the size of a star nursery, and gravity says, "I suppose this concerns me." It pulls the gas inward. The gas heats, the pressure rises, the nuclei get crowded, the strong force and weak force begin arguing at industrial scale. Fusion starts, a star is born. So yes, the gravity mechanic generally ignores nuclear disputes unless there is a whole bunch. One atom gets unstable and gravity shrugs. A trillion atoms gather into a star and gravity finally puts down its coffee. This is why stars exist. They are not just balls of gas. They are giant intervention meetings between gravity and nuclear rage. Gravity squeezes, the nuclei resist, fusion burns, light escapes. The star shines because a large number of tiny mechanics are angry under pressure. Eventually, the star runs out of easy fuel. The hydrogen is used up. The core changes. New elements form. Helium becomes carbon. Carbon may become oxygen. Larger stars keep going, building heavier and heavier elements in hotter and stranger nuclear rooms. This is stellar nucleosynthesis. Or, in wrong language, stars are grape factories with anger issues. They make carbon, oxygen, neon, magnesium, silicon, sulfur, and eventually iron. Iron is a problem. Iron is where fusion stops being profitable. A star can get energy by fusing lighter elements up to iron, but after iron, the math becomes rude. The star can no longer earn energy by fusing its core material. The nuclear mechanics look at the iron and say, "This is no longer in the grant." Gravity, however, is still there, waiting, patient, unblinking. If the star is massive enough, the core collapses. The outer layers explode. This is a supernova. A supernova is what happens when nuclear physics stops paying rent and gravity takes the building. In that explosion, heavier elements are forged and scattered into space. Gold, uranium, iodine, and other heavy elements are created in violent cosmic events and spread through the galaxy. This means your body contains atoms made in stars and stellar explosions. That sounds poetic. The wrong version is better. You are made of ancient nuclear paperwork ejected during a gravitational eviction. So as you drift towards sleep, remember this. Nuclear physics is angry mechanics in the grape basement. The strong force holds everyone in place. The weak force changes the forms. Radiation is what leaves when the meeting fails. Fission is an office split. Fusion is a forced merger. Half-life is patience running out statistically. Gravity usually ignores it unless there is a whole bunch. And the stars shine because somewhere deep inside them, tiny, furious workers are still arguing about whether hydrogen has been properly converted into light.